this video is dedicated to just talking about logs. What are they? Logarithms are functions that basically undo exponentiation. One way to define a logarithm is that it's a function, f of x, equal to some log base b of x, sometimes denoted as y. F of x is always denoted as y, or f of x. Y is the output, f of x is the output, x is the input. So that's what we deal with it. Now, when we say log base b of x is equal to y, this can translate, this mathematical expression can translate to a sentence in English. It stands for, I'll put it in quotes, b raised to the y power results in x, or equals x, okay? What do we mean by that? Well, take a look at this. Log base 2 of 4 should equal 2, because 2 raised to the second power is equal to 4. Log base 3 of 27 is equal to 3, because 3 raised to the third power is equal to 27. Okay? Log base 5 of 25 is equal to 2, because 5 raised to the second power is equal to 25. Here's another one. Log base 10 of 1,000. What is this equal to? It's equal to 3. Because 10 cubed is 1,000. So the base here, b, is what is being taken to the power y to get x. So this is called the logarithmic form. This right here. But there's also an exponential form. We can discover the exponential form just by reading it as a sentence, but we can also discover the exponential form by applying some properties of the logs. Let's just do it by the sentence. B raised to the y power equals x. Let's just write that out. That right there is the exponential form of a log function. We just read what this sentence is saying. It's as if we're translating one language to another. It's like we're translating log language to exponential language. And from exponential language, we can go to log language as well. And here's how we do so. All you need to know is that starting from one side, you can get to the other, okay? Let's define something called the power rule, okay, of logs. This says that the log base b of some quantity x raised to the p power is the same as p log base b of x. All right? We are about to use this right now, and every time we use it, we're going to say PR for power rule, okay? Take a look at b raised to the y is equal to x. All right? That's the exponential form of a log. I'm going to take the log base b of both sides. All right? That means I get log base b of b raised to the y is equal to log base b of x. All right? Now, using the power rule, PR, that power, P is P here, but here it's going to be Y. So the Y comes out in front. So we get Y log base B of B is equal to log base B of X. Okay? Lastly, the way we restore the logarithmic form, because we're going from exponential form to logarithmic form here, from exponential form to logarithmic form, the way we restore this equation right here is we realize that log base b of b is a question saying to what power must I raise b for it to equal b? The answer is 1. So this whole thing is equal to y times 1, which is just y. So I get y is equal to log base b of x. And take a look. This is the logarithmic form. And we started out with, right here, the exponential form. The exponential form went to the logarithmic form. Now I will show you, given the logarithmic form, now we're going to go to the exponential form. Doing this will allow you to understand what this is talking about. To go from exponential to logarithmic, we needed the power rule. To go from logarithmic to exponential, we need to know a special property of logs. This is the property. I'll call it log property, or LP. It states that if we have b raised to the log base b of x power, this is equivalent to just x. Right here. That's all you need to know. The log property, LP. b raised to the log base b power of x is equivalent to just x. Meaning, if I just have this equation right here, log base b of x is equal to y. If I do what I do to one hand side, I do to the other. I take the left hand side, I say b to the left hand side power, and b to the right hand side power. So what was in this equation is now powers. They're now exponents. And given the log property, LP, allows us to say that x is equal to b raised to the y power. But notice that this is just the exponential form. So now you know, with the log property, you can get to the exponential form. And with the power rule, you can get to the logarithmic form. Okay? This allows you to solve equations. Okay? What kinds of equations? Well, let's see. I'll keep the power rule up here. But let's say you have an equation like log base. No, actually what I want to do is, let's say you have 2 raised to the x plus 3 is equal to 5 raised to the x. We want to solve for x, okay? I can't solve for x just by saying x plus 3 is equal to x, because they're not the same base. 2 and 5 are not the same base, nor will they ever be the same base. You can never make 2 or 5 equal to the same base, because 2 and 5 don't break down anymore. They're prime numbers. So what we can do is use the power rule here. We can take the log of both sides. It doesn't matter to what base. The base does not matter at all. So we can pick log base e. We'll pick ln. Take the ln of both sides. So I get ln of 2 to the x plus 3 is equal to the ln of 5 to the x. The power rule still works for ln. It's a log. So that x plus 3 comes down, and make sure you use parentheses. ln of 2 is equal to x, ln of 5. Alright? Now, ln of 5 and ln of 2 are just numbers, and we can solve for x now algebraically. Moving the calculation here, divide both sides by x, divide both sides by ln of 2. I get x plus 3 over x is equal to ln of 5 divided by ln of 2. What I did was, I first divided both sides by ln of 2. That way I got x ln of 5 divided by ln of 2. Afterwards, I divided both sides by x. That way I got x plus 3 divided by x is equal to ln of 5 divided by ln of 2. Now I can distribute this x to both terms. X over x is 1. X over 3 over x is just 3 over x. Alright? So now I can send that 1 packing. I can subtract the 1 from both sides. So I get 3 over x is equal to ln of 5 divided by ln of 2 minus a 1, because I subtract the 1 from both sides. Next, I can make sure that they have the same denominator, because this is divided by 1. So multiplying top and bottom by ln of 2, I get 3 over x is equal to ln of 5 minus ln of 2 all over ln of 2. Okay? We're almost done solving for x. What we can do is take both sides to the negative 1 power. Doing so flips the equation. X goes on top, 3 goes on bottom, and over here, the denominator becomes the numerator, and the numerator becomes the denominator, okay? So I'll move the calculation to up here. Now I get x over 3 is equal to ln of 2 divided by ln of 5 minus ln of 2. And feel free to take both sides to the negative 1 power whenever you feel like. Whatever you do to one side, you do to the other. It's totally fair play. To solve for x, I multiply both sides here by 3. Alright, that means x is equal to 3 ln of 2 divided by ln of 5 minus ln of 2. Done. So that's the power of the power rule. The power of the power rule is that you can bring variables from the upstairs downstairs. And you can solve for equations that way. But you can't solve for them when they're upstairs, especially when they're not at the same base. These log properties are also useful, as I will highlight in an example here. Let's say your variable is inside of a log. Oh no. Let's say I have log base 3 of x plus 3 is equal to 4. And I want to solve for x now, and I can't solve for x inside of a log. That log needs to go away somehow. We got to make it go away. How do we do it? We use the log property, okay? The base is b, so I'll put a 3 here and a 3 here, okay? Now, all that remains is what's inside the parentheses, x plus 3. And on the right-hand side, you have 3 raised to the 4th power. Uh-oh, what is that? 27 times 3? Okay, this is going to be hard. 27 times 3, 3 times 2 is 6, 3 times 7 is 21, 6 plus 20, 60 plus 21 is 71. Hopefully I did that right. Let's see. No need to guess. We can just keep it analytical and subtract by 3. So I get x is equal to 68 by subtracting 2. I'm not good at mental arithmetic. What is 27 times 3 here? That's 14, 21, 1, 2, 6, 7, 8. Oh, so it was 81. Not 71, but 81. So this is 78. All right. 78. When I subtract 3 from 81, I get 78. Okay? Very good. Very good. So now you know how to utilize log properties. Thank you very much for watching this video on logs and how to use them.